the die class. And we already discussed all this, as I said, okay? This is a constant, an integer face value. We call this an instance variable, okay? It's the attribute, and a die has only one attribute, the top, right? The row is a method. We discussed all this, really. So I'm not going to go through this again, okay? Okay, this is something I'm trying to explain to you. If you look at this, okay, there are also methods to explicitly set and retrieve get face value, the current get face value, the current face value at any time. Notice that you have to call either of these two methods to deal with the instance variable face value, i.e. to change it or to obtain it. There is no other way. So if you look at this example, let's go to rolling dice. Okay. So in my rolling dice, can I directly say, give me the face value? What is the face value? Can I do this? Okay. Just do face value. Can I do this? I cannot do this. Why? Because face value is, if you look at it, it's private. So when we say it's private, it means it's only valid in this class. It's not visible outside. So here, there is no way you can access face value. No way you can change face value unless you use the method get face value, okay, or set face value. So that's what this is about. That's what that was talking about. You provide the methods, not do it, right? Okay, it doesn't let me, okay, good. So that's what this means. If the die class does not provide get face value, there will be no way to know what the face value is unless you print out the object. So there's no way to change it. There is no way to know what it is. That's the methods. So that's why we make this private, this die, okay? We make it private so that no one can change it unless I give you the tool. And what is the tool to change it? Set face value. So if you comment this out, if you don't have this method, you cannot change anything about the face value for the dice. That's what that is, okay? The toString method, I already discussed the toString method. You always define the toString method for the class. Let me ask you this question. What does the toString method return?
A character string?
Yes, a string. A string of, okay, a concatenated string of all the instance variables. Okay, so the toString method returns a character string that represents the object, the description of the object. How do you describe an object? You use the attributes, right? So that's why the toString method returns a concatenated string of all the instance variables, okay? Instance variables are the state of the object. And in the die class, there is only one instance variable, face value. Max is really, I told you, a utility variable. Okay. And I also last time, if you don't remember, go back to watch the video. I discussed this, right? This part we discussed. And it's also convenient for debugging problems. So a lot of times you can use the toString method to debug your object to know what's wrong. Constructors, okay. Okay, a class should always have a constructor. You don't have to, but you should always have a constructor. A constructor has the same name as your class. We already said that, okay. The constructor is called when the object is created, and we discussed all that, right? once again, I use this class to discuss all that already. And here, this is calling the constructor, right, of the die class. So it's called when you create an object. Okay, I will let you read this. I don't need to. I will let you read. Data scope simply means where that data is valid. And we discussed this in class 1 in Python already. So if you look at this program, okay, the data scope of these two variables, they are called instance variables. The data scope is the whole class, okay? Now here, the data scope of this variable result is this method. That means result cannot be seen anywhere else. It's not visible to them. It's declared in this little house, in this little method. So if you try to access result here, for example, it will say, I don't know who you are because you are not here and you're not in my house. So who are you, right? That's what data scope is. So it's declared in this method, then the data scope for this variable is this method only. Other methods cannot access it. But these are called the class variables because they are accessible. Any method can access it. If you see, they are all accessing it, right? So that's data scope, while this one is only accessible in this method. That's what that is. Okay, any questions? And we call that local variable. It's local to that method only, while the instance variables are called class variables because they are valid throughout the class. Any questions? Okay, we discussed that. And instance data. Okay, a variable declared at the class level is called the instance data. And we discussed this already once again. Okay, so these are called instance data. Okay, but as I said, this is more of a utility method, a utility variable. So it really isn't the instance variable. This is the true instance variable. So what is an instance variable? An instance variable is an attribute that belongs to that instance. An instance is the realization of the class. That's called an instance. An object, we call that an instance. Okay, so instance variables are the attributes for that object. And think about this 6, it really, because when we are looking at a die, we are looking at the top, right? In our project, that's what we are interested in. Okay, so that's the instance variable. We say an object is an instance of the class. Each instance has its own instance variables, and that's why these variables are called instance data. Okay, just like you know, you are all students. You all have an age attributes, but your ages are different. So each one has different instance data value, but you all have the same instance variable, such as name and age. But the values for those variables are different. Okay, a class declares the type of the data, but it does not reserve memory space for it. The memory space is reserved only when an object is created. Each time a die object is created, a new face value variable is created as well. That's when the memory is allocated. So if you look at this, okay, so when you simply define this class, nothing is reserved, no memory, nothing. It's just the class. But when you call it, when you do this, okay, now memory is reserved. And in that little die memory space, there is a variable named the face value, and its value is 1. That's when the memory space is reserved. Okay. The objects of a class share the method definitions, but each object has its own data space. And that's what I'm trying to say, right? You all have name and age, but each of you have a different name and age. Name and age are universal attributes for a student, but the values for each student is different. Okay, that's the only way two objects can have different states. And you have methods, but the methods, you have the same methods. For example, register for a class, change your name, change your address. You all have those behaviors common to all of you. But when you change your address, you have your own address that's specific to you. So when you call the methods will operate on the specific data that belongs to that specific instance. Okay. So if you look at this, now this is style 1, right? This is the object. It points to a location because it's a reference variable. So this is the location for the object. And here is the instance variable. Both of them have these same instance variable names, but their values are different. So they each occupy a different space. This object is occupying this space, and this object is occupying this space. Okay. Any questions? Okay. One thing to remember is that when designing a class and define the instance data, the private instance variables, you need to only define those that are must-haves, those that are basic, fundamental, those that describe an object. Some attributes are derived, meaning that they can be gotten from the basic fundamental attributes. And I will let you read this example. Let me ask you another question then. If you have a student class, okay, you have a student class, and you have instance variables, first name, last name. Should you have, okay, let me give you this example. You have a student class, you have instance variables, first name, last name, full name. Is this correct?
No.
No?
You wouldn't need full name.
Daniel, explain why you don't need full name.
Because you can just concatenate them separately. You don't need need to set aside a variable for it.
Okay, good, very good. So Daniel, what is full name called? What do you call that attribute?
Derived.
Yes. Okay, those are derived attributes because you can get them from the original, from the more native attributes. Okay, that's what this is. And there is a danger if you have derived attributes, because pitfalls of the derived attributes. I will let you read this. Everybody, do you understand this? Yes or no?
Yes.
So having derived attributes would make it so that you can change it to be whatever you want, and it ends up with an undesirable result.
Yes, and this is an example, right? Your length is 3, your width is 4, your area should be 12, derived 12. But if you have area as a private instance variable and you provide the setters and getters, for private instance variable, you always have to have a get method and set method. So you have those methods, and then you can set your area to whatever it is, to whatever. So you can set it to 36, to 48, to 60. It has nothing to do with the length and width anymore. So that corrupts the object. Yes. Okay. Any other questions? Okay. UML diagrams. UML stands for the Unified Modeling Language. Okay. It's not Unified Machine Language. It's not Universal Modeling Language. It's Unified Modeling Language. UML diagrams show relationships among classes and objects. If I tell you the relationships between two objects, it's my English. In English, all human languages are ambiguous. you can interpret it many different ways. Think about today's world. In today's environment, you have to be very careful when you say something because it can be interpreted multiple ways and you will get into trouble sometimes. So that's why make sure before you post anything on Facebook or anywhere or say something, you be careful. And I don't like this at all, to tell you the truth. It's very much like when I was in China. I'm going to stop recording this. Human languages are very ambiguous. You can interpret it multiple different ways, but a diagram, okay, you look at it, it has one interpretation. That's why we use UML diagrams. So a UML class diagram consists of one or more classes. Let's look at it, okay? So this is a UML diagram. And this is a class, this one. This is a class, okay? This is called a class. If you look at it, it has 3 sections. Class name, and this is for attributes, which are the instance variables, and this is for methods. Okay, those are the 3 sections. So here, this is the class name, attributes. Notice that max value is not here, right? Because it's really not the attributes of a die. That's just for utility purposes, once again. And these are the methods. Okay, if you look at the attributes, face value is the name of the attribute, and colon, and then you have the data type. So this is saying face value is of an int data type. And this is the method. Notice how you signify methods, okay? Method name, parenthesis, and data type. This is the return type, okay? And method name, parameter. For parameter, you do not have to have this. You just need to specify the data type. And return type. Method name, data type, return type. Method name, return type. So that's what a UML diagram is, okay? And so you have 2 classes. Remember last class I said, for Java, it's all about relationships. It's not the for loop or if-else statement. Those are way in the past. We use them to accomplish what we are doing now. So now we are not concentrating on the for loop, the if-else statement, the switch statement, because they are the given. You have to use them to construct objects. That's why your first project is all about that. Now it's not about that. You have to be able to proficiently use them to construct your object. Okay, so class name, instance variables, and methods. Okay, that's called UML class. This is a class, right? And there are 2 classes. So you establish the relationship. So if you look at this class, okay, I'm going to ask you, who do you think is using whom? What is the relationship? Which class is using which class? This is a die class.
The rolling dice is using the die class.
Yes, very good. The rolling dice class is using the die class because you see, you're using it, right? You are referencing it. So you are using the die class while die is being used. Die is being used. So that's the relationship. And this is telling you rolling dice is using the die class. Okay, that's the relationship. Any questions? We call this relationship uses or use. Okay, so rolling dice is using the die class. And I did another diagram. Let me show you. Okay, so do I still have it? Okay, we are going to write this class at the end of the class. Okay. So look at this. This is Glyphy. Okay, you go to that website, sign up for free. I did a free one. And you can go and find UML class and go there and just drag one here, and you can write a class. So for your project, you know, every class must be used or used. They have to have a relationship. If you have a class that has nothing to do with the other classes, that means it's useless. You need to get rid of it. So here, computer store is using computer. And if you look at computer, this is the class name. And here I have several instance variables. OS, it's a string, Windows or Mac or Linux or Unix. Hard disk, the storage space, right? Int, random access memory, RAM, that's int, and CPU speed, double. And then I have these getters, get OS, get HD. So get OS returns a string, get HD returns an int, etc. And set OS accepts a string and returns void. Okay. And then I have an evaluate method. We will do that, but this is the UML diagram. Okay. Any questions?
You always get a void when you set something, return a void?
Yes,
or
exactly,
nothing?
exactly. When you set something, it's always void. You always returns void because you are changing something. You are not returning anything. What is the relationship between a class? I will just put this answer here. A class is a definition. It's the blueprint. An instance, an object is an instance of that class. You have one class, you can have multiple objects or instances created from that class. Instance data is at the class level. That's the class variables. Every method can see it, can use it. What is the scope of instance data? We just answered that, right? What is local data? Local data is like the result in the toString method. It's only visible and accessible in the method. Okay, let's look at encapsulation. There are two views of an object, internally and externally. So internally, the internal state is the details of the variables and methods of the class that defines it, defines it, okay, the class. External, the services that an object provides and how the object interacts with the rest of the system. So let's look at this UML diagram, okay. Internally, this is the internal view of this computer class. Okay, let's go to the rolling dice, right? Since you are more familiar, we haven't written that yet. Okay, internally, this is the internal view, okay? And this class it cannot see this because it's private. It can these methods. So those are the interfaces you can see. Okay, so if you go to this class, this whole thing is the internal view of this die class. Why? Because you can see how it's implemented. You can see the instance variables. You can see even the final variables. You can see how it's implemented. These are the implementations for each method. So this is the internal view. I will just go there. Okay, so that's the internal view. Externally, for rolling dice can only see the methods. It doesn't know the instance variable face value. It cannot access it. It only uses the methods. It does not know how row is implemented. It does not know that. It does not know how get face value is implemented. It can only use it. That's the external view. Okay, that's what that means.
I have one question.
Yes.
Whenever you set, you know how you set stuff like methods to public or private?
Uh-huh.
You can still externally like implement them, I guess, if they're private?
Okay.
Like if you're going to go to that one or the other one, the die class itself,
Okay.
and you were instead of, well, for the set part, right, for the mutator, instead of changing that to public void, can you set it to private void? Would
Yes,
you
but
still be able to access it from
No.
rolling dice?
That's a great question. If you change it to private, you cannot access it at all from outside. So if you do it from outside, if you change it to, that's a great question. And we will discuss the public, the accessor in a minute. But if you make this private, then from outside, you cannot access it, okay? Let's go to rolling dice. And you can see it will say this method is not visible. You cannot see it, so you cannot use it. Okay, so that's the difference between private and public. I'm glad you brought that up because that's something we will discuss in a minute. Okay, any other questions? Great questions. So if there is anything you want the object that uses you to see, you make them public. If you want to encapsulate, hide them, you make them private. Okay, you need to read this on your own because I don't have much time. So you read it. This should explain the external and internal. Okay, you read this. Read this. Yeah, read this. Okay. Okay. Let me ask you. You should, to be honest with you, you should have read this beforehand, right? I said read the lecture notes. So I'm not giving you too much time in class. So if you look at this, I'm going to ask you, who is the server provider? Who is the client among these two classes? Die and rolling dice. Who is the provider?
Would be die.
Die is the provider. Okay. Who is the client?
Rolling dice.
Rolling dice. Who was answering the question? I cannot see. Tell me.
Oh, that's me, Aaron.
Aaron, that's correct. Very good, very good. Okay, rolling dice is the client because it's using the die class, right? The client. And die is the provider because it provides services such as roll and get face value, set face value, etc. So die is the provider and rolling dice is the client. Okay, and I already discussed this part. Any changes to the object state should be made by that object's method. You cannot directly change the face value. We already talked about that. Okay. So, okay. Okay, as a client, you really can only see the methods. If you look at this, the client can only see the methods. You cannot see the instance data. And the instance data are only manipulated by the methods. The client does not have direct access to the data, so it cannot manipulate the data unless it uses the methods provided, which is set and get. Okay, any questions? Okay, here is what just now Jesus was asking, right? In Java, we accomplish encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word. Not modifier itself, but these. Final is a modifier. That means you cannot change the variable. And then there are three of access modifiers: public, protected, and private. Public, that means everybody can see it. Clients, bystanders, wanderers, whoever. Okay, protected can only be seen by the children of a class, which we will discuss later, by the same class, by the classes in the same package. And a private can only be visible inside the class. So this is outside the class, this is inside the class, and this is inside the package. Okay, if you do not define visibility, by default, it will be protected. So here, if you take this away, okay, it will be protected. And that the danger is any class in the same package can access you. So you always make sure you put accessor there. Okay. You can read this on your own. Okay. We talked about this already. So public, you never make your variables public. So you never do that. Okay. Your methods should be public, and your variables should always be private. And some methods can be private if they are supporting methods, which we will discuss later, but not in this chapter. So variables, instance variables, private, methods, public. Okay, accessors and mutators. We discussed this in the first class. I'm going to briefly discuss it, and then because I want to do another example. Okay, because instance data are private, a class usually provides services to access and modify instance data values. Remember, because they are private, if you don't provide methods, there is no way the client can access it or modify it. So we provide an accessor method, returns the current value of the variable. A mutator method changes the value of the variable. So if you look at this, this is the mutator, right? It changes the value, right? Whatever value you give me, I'm going to change it to that value. And here, get value, get face value will return whatever face value it is. It will return it. So that's that. And the names of accessor and mutator methods take the form of getX, setX. So your method, your instance variable name is face value, and so you will have get face value, set face value. Okay, they are called getters and setters. We don't have to do that. Okay, anatomy of a method. So we discussed this in Python. So you are already very familiar with how to write functions. And this is very similar to function definition. So let's look at it. A method declaration specifies the code that will be executed when the method is invoked. Okay, when a method is invoked, the flow of control jumps to the method and executes its code. When complete, the flow returns to the instruction. It's just like this. Okay, so in this method, you are calling another method, right? So the flow of control will go here, execute the code, and return back to the next statement and get out. That's the flow of control. I will just let you watch that, right? Okay, so let's watch it again. Okay, so this is the main method, and you have an object, and you call do it. It will come to do it, and it will execute. And in do it, it's calling help me method, and so it goes to help me and execute all the statements here. Comes back to after help me, and go forward, and then return back. So that's what return means. You go back to whoever called you. Okay. So we discussed this in class 1 already. This is the method header, and this is the return type. That means what you want to give back to the calling method. Okay, these are called the parameter list. This is a parameter list. These are called parameters. So for your parameter, you must have the data type, right? Data type. This is not in Python. In Python, you do not have to have the data type. But in Java, for each parameter, you must have a data type. That's the difference. So you need to remember that. Okay. 3 parameters, 2 different data types. And you should always, when you call the method, let's look at how you call the method. Okay. When you call the method, oh, this is the implementation. Okay, so this is the method header, and this is the body. Okay, in Python, you just indent, but in Java, your body has to have the curly braces and the body indent. Okay, so this is the method body, whatever you do. And the last statement is return. I explained all this, so you can read it. If you don't understand, I'm talking it quickly, going over it quickly. So return result. Why do we need to return? Because it has a return type, char. So you need to give back a char, and your result is a char. Okay, you always give back whatever the return type is. Okay. We discussed that already. You can look at that. So here is how it works. Okay, this is the method definition, right? When you call a method, it will, you use the object name to call the method. And because this method returns a char, you assign whatever is returned to a char variable, ch. And this 25 goes to num1, count goes to num2, hello goes to message. So inside num1 is 25 because that's what is passing to num1. And whatever count value is will go to num2, right? Num2. And message, hello, hello, will go to num3, message. Not num3, it will go to message. So char at sum, whatever that number is, it will find that character and return that character. So when you call a method, you must make sure your parameter list matches your argument list. Actually, your argument list matches the parameter list in the number of parameters and the order of the parameters. You cannot put hello before 25 because the order is int, string. So you must have int, string when you call it. Any questions? Okay, another thing to remember, and this will be on your test, is these are called formal parameters because they are defining the function, the method. These are called actual parameters because they are the actual values that are being used in the function, in the method. Okay, so here is the method header. Suppose you have the implementation, and this is the method. So this call is correct. 12, 3, hello, right? The data types match, the number match, the sequence match, and this is correct. And this one is correct. 3 will go to num1, 45 go to num2, good, go to message. So this is correct. This one will not be correct. The reason is 12.5 cannot go to an int because it's a double. It doesn't go to an int. 3, okay, but the first one does not work. And this does not work because it's a char, while the method requires a string. Okay, this is a char. So that doesn't work. And this one doesn't work either because the first one should be an int, while here the first one is a string. That doesn't work. Okay, that's how you call a method. Local data, we already discussed that. So if you look at this, let me ask you, tell me which one is local variable in this implementation? What is a local variable? Do I need to stop recording because you're not answering? Both sum and result are local variables because they are declared inside this method and no one can see them. And Jesus was correct in saying that at the end of the day, at the end of this method, they will be destroyed. They will not exist anymore once the method exits. It's very sad, but they are called automatic variables. So they automatically are destroyed at the end of the method. You are used and you are thrown away. But the value, okay, here, remember, we are not returning a variable here. We are returning the value in that variable. Remember, what is a variable? A variable is a memory location, right? And in that location, you have the value. So when you say return result, which is a variable, you're not returning that memory location. You're returning the value in that location. And that location is being destroyed, okay? And we discussed this already. So local data, we discussed that. Bank account example. So I don't think I have time to do the example. Let's look at this example. Let's look at another example that demonstrates the implementation details of classes and methods. Okay, we'll represent a bank account by a class named account. Let's think, when you do a bank account, what are the attributes for a bank account? What describes a bank account? Give me something. I will just continue, right? Derek, I'm sorry, who said something?
Oh, like if we're asking about like a bank account, we're like, you know, the transactions, the balance.
Okay, the transactions, attributes.
Oh, attributes. Okay. Oh,
balance?
the balance for an attribute. And that, I mean,
when we say
that's what I was gonna say.
attributes, it's something that describes something. It's usually the noun, right? The noun describes something, attributes,
Okay.
you know? Okay, so balance is an attribute. You have an account. What's your balance? What else?
You need a name and an account number?
Name? Yes, the account holder's name and the account number, right? What else?
Routing number.
Oh, what number?
Routing number.
Routing number, yes, routing number, yes. Okay, so depending on what you do with that account, those are the attributes, right? Okay, good. So let's look at it. Very good. Okay, so its state can include the account number, the current balance, the name of the owner, and many others, but we pick the ones that are relevant to our task. An account's behaviors or services include deposits, withdrawals, adding interest, check balance, etc. Those are the behaviors and services. We will make them into methods. Let's look at this example. Driver class. Driver class, you are just, we call it the driver class because driver is testing the methods of the class. Basically, you are using that class, right? We call that driver. Okay. So when I say let's write a driver, I mean let's write a class with a main method to test all the methods in the driver, in the class. So rolling dice is a driver class. Die is the class, rolling dice is the driver class. So here, this is the driver. The driver has the main method, okay? So if you look at this public static void main, okay, we are using the class, right? We are declaring a variable and create a new account. So obviously this account accepts, this constructor accepts 3 parameters: a name, a string, an int or long, a double, right? Account 2, name, long or double, and double, or long, or int or double, and the same. So now you created 3 accounts or account objects using the same class account. So the class, that's why we say a class is a concept, a blueprint. So the blueprint is account. And now you're creating 3 different instances, different objects. And they all have those same attributes, but each attribute has a different value. Okay? And then you use one object to call the deposit method, and obviously deposit accepts a double, so you give it the number, right? And then you deposit, and obviously this deposit returns a value, so you assign it to balance, and that's how much you want to deposit. And then you print out this balance, right? Okay. And then you will withdraw, you gave some money to account 1, but you withdraw some money from account 2. This is the money amount you want to withdraw. This is the fee, right? Okay, we will look at the class, but so you add interest, call add interest for all 3 objects, and then you print out account 1, account 2, account 3. When you do this, when you call the object inside a print line statement, remember which method is being called, the toString method, right? So this is okay, but it's not necessary because it automatically calls the toString method. Let's look at the account class. Okay. This is, again, a final variable. It doesn't really, it's not the instance variable. We don't say they are the instance, it's an instance variable. It's a utility variable, okay? So here, these are the instance variables. That's why you see the formatting. This is above all of them, right? Because it has nothing to do with this, with each instance. It's just a final variable for utility purposes. So we have 3 instance variables: account number, balance, and name. We don't care about the routing number, obviously here. It's not relevant, but it is extremely important. If you are doing a real class account, you have to have the account number, the routing number, right? The Swift or something like that. Okay, so this is called the constructor, everybody. The constructor, if you look at the rolling dice, the die method, the die class, this constructor accepts no parameter, right? No parameter is accepted. This is called the empty parameter list, no parameter. Here, in this one though, this account, the same name as your class name, the account accepts 3 arguments. And so it just assigns the name, the owner given to name, assign the account, that's the account number, and initial, assign it to balance. So after you call this account, your account now is in good standing because you do have account number, your balance, and name. So you have created an account. And that's what this is doing, right? You have created 3 accounts. Okay, and that's that. Any questions? Okay,
so a new account's going to be account 1, account 2, account 3, and so on?
Yes, yes. So here, you use this one blueprint, which is account, but you created 3 accounts in your driver here. You created 3 different accounts. So account is the class, the blueprint, the cookie cutter. Account 1, ACCTY, ACCT2, ACCT3, ACCT1, not Y. These are the instances created from that class.
But there's no way to do it without giving it like a new account, like ACCT4, you have to type that in. There's no way the system will automatically do it for you, right?
No,
there's no shortcut.
Mm-hmm.
Okay.
Yes, you'll have to create it. It doesn't exist unless you create it.
Right. So I just have one question. So it's kind of like on the scanner class, you can name your scanner anything. So you don't have to name it ACCT1. You can name it whatever you want to call it. Yeah.
Yes, you can say my account, your account, his account. Yes, that's just a name.
Right.
Just like these are just names. Remember, variables are just names, right? They are just names, and you can name them anything, but you want it to be meaningful. Okay, so that's that. That's what do you call this, everybody? Once again, what is it?
Constructor.
Constructor. This is the constructor. Your constructor is always public. It's always has the same name as your class name, no return type, okay? And in your constructor, what do? You initialize all instance variables. So you have 3 instance, and now you give each instance variable a value based on what is passed. If it doesn't give you a value here, okay, if you take that away, if you don't have a value, if this public account accepts 2 parameters, okay, like this, you still have to initialize balance to a value 0. So no matter what, your constructor, the purpose of your constructor is to initialize all instance variables to a value, given or not, okay? So if you don't have this parameter, if this constructor accepts only 2 parameters here, then you still have to initialize balance to a default value. In this case, we initialize it to 0. And that's very important to remember, okay? Questions? Okay, deposit, public, return type is double, and accepts a double amount. And so your balance, where is balance, everybody? Where do you get balance?
Balance is brought in.
It's here, right? That's your instance variable. Remember, these are called class variables. Give me a minute, I need to. Okay, this is the instance variables. They are visible throughout the class, remember. So balance here, and after an account is created, balance already has a value, right? So we come here, it already has a value. So we add whatever amount you give me, add them together and assign it to balance. So now your balance is changed. If originally it's 10 and you give me another 10, now it will be 20. Okay, any questions? Why do we have to return balance? Why? Why do I have to return balance, everybody?
Because that's what's getting updated when you run that method. Okay, because this method requires you to return a value, right? It declared in the method header. So it's like you make a declaration, you have to accomplish it, you have to implement it, you have to let it be true. So in your method declaration, you are saying, I'm going to give you back a double. If you use me, give me a double, and I will give you back a double. So that's what this is saying. Give me a double, I will give you back a double. So the double you gave me, I will use it to update the balance, and then I will give you back the balance. So you must have the return value. Okay, and here, withdraw, give me the amount and give me the fee. And then I will subtract that amount, subtract the fee from the current balance and update the balance. So now your balance has changed. Okay, if originally your balance is 20, after this method, someone called you, right? The driver calls you. And now if the amount is 5 and the fee is 2, you will subtract 5, subtract 2, it's 13. So your new balance will be 13. Whoever will access the balance, now your new balance will be 13. And return balance. Once again, why do we have to have this statement? It's asking, it'll return double if you enter a double.
Yes, because it says so. You said so. You know, when you declare your method header, you say, I'm going to give you back a double. You have to keep your promise and give back a double. Okay. Add interest. So you add the interest, you just calculate and update your balance, right? And because you said I'm going to return a double, you return balance. This is not necessary. I don't want to confuse you, but this is not necessary actually, because you're updating balance, and your balance is a variable here that everybody can access. So after you add interest, you can simply say get balance, and you will get the new balance, but you don't have to understand that right now. Okay, get balance, return the balance. ToString. What does the ToString do, everybody? Once again, what does the ToString method do?
Returns a string.
Of what?
A string character.
Of what?
Oh, hold on.
Object of all the instance variables.
Of what?
Of all the instance variables.
Yes, that's correct. It returns a string of all the instance variables. So account number, name, balance, right? Remember, I said the rate is really not an instance variable. It's a utility variable. So you return the basic. Why do you return the instance variables? Because those instance variables describe this object. So you say ToString. Basically, you are asking the system to describe the object for you. And how do you describe the object? You give it all the instance variables. And that's how you describe the object. So we discussed this last time in chapter 3. So you're just formatting the balance into currency method, currency format, and you return all of them using the escape sequence character, right? Okay, so so that's what you see. That's the ToString method. That's accomplished by these 3 statements, right? Okay, and you can see withdraw, that's calling the method. Withdraw requires 2 double, so you have to have 2 double. Add interest doesn't require anything, so it's empty parameter list. And account is the constructor, requires 3 parameters. Does this help you understand it, everybody?
Yes.
Okay.
Yeah.
Yes.
Okay,
Yes.
do you have any questions about this?
I do have one. So
Okay.
it's more of so on this specific program, it's not asking you to input your own data. It's already got the data for you when it comes to like the balance and everything.
Yes, you don't. What you're talking about is, should we use a scanner to do this, right? Yes, you can. But this one is where is it? Here, right? Here, it didn't ask you to input the data. A driver, a lot of times, it's just testing to see if the class is correct, if the class, your design is correct. So this is just testing it using a fixed set of data.
Okay.
Can you get user input? Yes, you can declare a scanner method object here and just say, enter the name for the account and put that variable here, right? You get it, you put it here. Enter the account sum balance, and you put it here. Yes, you can do that. But this is just, you don't have to, because here, that is already way too simple. That's already in the past, unless your project requires you to do so. Here, our main purpose is to test, to see if the class is correct. Yes. Okay. Any other questions?
Kind of going off of his question. Let's say, well, because lately we've been, or for all the class, we've been doing programs that start at 0. If you would, you know what I'm saying? Start at 0. Like we have to put new variable or all the information for those accounts, right? If we're talking about this one, like we have to put Ted Murphy, the account number, and the original deposit amount. Is there gonna, be a time where that information that was stored previously gets saved to a different file?
Oh, that is, I have it here. I forgot. No, right now, no. In class 3, yes, not now. I have it here. I forgot. Okay, no. In class 3, you will learn how to sequencing them, how to sequence them, the bits, and save all this data into a file. Yes, but not in this class.
Thank you.
Mhm. Any other questions? I have it here. I forgot. No question? Okay.
Nothing.
I don't have much time. If you have questions, I have time. If you don't have questions, if something is here, you can read it and you can understand it, I will pass through quickly. But I'm so much willing to answer your questions because that's how you learn, right? So if you have questions, please ask. Questions?
Can you kind of go over what is it? Overloading a constructor?
Okay, are we talking about that somewhere? Okay. Overloading a constructor. I think in Python, we did discuss overloading.
That was on the dog example, the video.
Oh, okay. So overloading example, overloading means you have two, not just constructor, you have two methods with the same name, but you can have different implementations because you have different parameter lists. So if you overload this means you can do this. Okay, public account. Okay, so this is overloading. If you look at this, this is the same name as this class name. So it's a constructor, right? But it does not accept these. So that means that you can just create an account with nothing. So then you still remember your constructor is to initialize all instance variables. So I need to initialize them. Name, what is name? I will say unknown, right? And account number, oh, it's long, right? It's equal to what? I will say 0 because, 111, maybe just the default value. And then, oops, I'm doing the Python without the semicolon. Okay, and then balance, 0. You see, now, so here, once again, so here, these are the overloaded constructors. What this means is you have two constructors, okay? One accepts nothing, and you still have to initialize all of them. One accepts the values from the user, and you initialize your instance variables to those values, right? To those values. Okay, those values. And let's do another one. You can overload it as much as you can, actually.
Isn't that like a default constructor, or is that something else?
This one is called the default constructor.
Okay.
You are right. I don't know if I discussed this in this class, but okay, long. Let's just have a balance. Okay, double bit balance. Okay. So in this case, I don't remember if I discussed this, but because this name is the same as this name, the name for this variable is the same, you want to differentiate them. Okay, remember the one on the left is always, you have to, if you don't remember, you have to go back and watch. The one on the left are always the instance variables. So here, if I say name, this is the instance variable, but your parameter variable is also named name because you cannot think of a better name to describe this variable. So you use name again. So what you do is you need to differentiate them. Tell the system which is which. So you use this. Okay. This dot name means this is referencing this name. You see now, you don't see the confusion of the system, right? It knows when you see this dot name, when you say this dot name, you are referencing the instance variable, and this is this name. And you can see this is this name. Okay, that's how you differentiate them. And if this is balanced, once again, you don't have a better name for that variable, then you will do this. This dot balance equals to balance. Okay, so this is the instance variable here. This is this parameter, this argument here. Okay, you use this to differentiate. The ones on the left is always the instance variable. So this should always be attached, be preceded for the variable on the left. And remember, your constructor is to initialize all variables. So you still have to do a count number, even though you don't have a value given to you. So you will just do a 0. Or 999, you know, whatever you want to do, right? Okay, so these 3 constructors are overloaded, okay? In my transaction class, I have done 3 of them. So I can do another one, ACCT4, and I can just say new account. So now, if I do, okay. I cannot type, so ACCT4, right? Plus, let's see, let's put that object here. You will see. Okay, I'm going to run it. Okay, you will see ACC count 4. This is the balance. This is the name. This is the balance, account number, and name, right? Account number is 0. Name is unknown, and balance is that. That's because that's what we did. When you do this, you are calling this one. You're calling this one, right? Okay, so let's do one more. I will do this one and you will see, right? Okay, so and let's do an account 5, okay? And new account, we only have what? We only have a name, new name, and we have a balance, right? Let's give it 450, and let's print it out, okay? And then later you can use get balance, set balance, get name, etc. to do all that, of course. So let's do account 5. Okay. Okay. And you can see your account 5, your account number is this, and your name is whatever you give new name, and your balance is 450. So that's because you did that here, right? When you did that, you did that here. So you can also see why I said you need to initialize all your instance variables. If you do not do that, your account number would not have a number. Your object would not be complete. So you need to complete your object by initializing all variables, all variable names. Okay, any other questions? Okay, we discussed all this, right? Okay, I will let you read this. Oh, I did that, default constructor. Oh, I did that, right here. So look at this. The structure of a class, everybody. I know it's a little bit over the time, but I want to go through this. So I give you this template. If you look at it, it's a template for how to write a class. So public class, class name is in this title case, uppercase, okay. Declare your instance data. They are always private, okay? And so always private. Constructor has the same name as that of the class, always public, no return type. Its purpose is to initialize all instance variables to a default value such as 0 or depending on the type or to the values passed through the parameter list. So here, because you don't have any values given in the parameter, you initialize them to default values. Here, you are given some values, so you initialize them, but also initialize account number to default value. Here, you are given 3 variables, so you initialize all 3 to whatever is given, okay? Then, constructor can be overloaded. Yeah, I'm talking about that here, right? So I already discussed that. Why do you overload a constructor? Because you have different parameter lists. You are giving the customer, the client, the convenience of being able to create an account with nothing, or an account with only a balance and name, or an account with balance, name, and account number. So that's that. Mutators, always public, return type void, name starts with set, okay? And followed by the instance variable name. Parameter list contains 1 parameter with the same data type as that of the instance variable that is to be changed. So mutator, let's look at this mutator. What is the mutator here? Oh, it doesn't have a mutator in this one, it didn't. So let's look at this mutator. Set face value, void return type set, and the face value is the instance variable, but you uppercase, you capitalize F, right? It always accepts a value, a variable that is of the same value as your instance variable. That's what I meant, okay, here. So with the same data type as that of the instance variable that is to be changed. Accessors, always public, return type is the same as that of the instance variable to be accessed. So get face value. Return type is the same as the instance variable that is to be accessed. You're accessing face value. Its data type is int. So your return type is int. And you have really, you start with get followed by the instance variable. Okay, so that's that. Parameter list is empty. Other methods such as row here, it's just a method other than the accessors and mutators. And toString is always public, return type always string, no parameter is accepted, return a concatenated string of all the instance variables, formatted if you like, okay? So you will watch the videos, and that is the end of this class. When you write a class, make sure you look at this structure, this template, and write your class accordingly. Okay, everybody?